AS Pure Mathematics, going over the first few chapters for AS Pure Maths for Pearson Edexcel, AQA, OCRA, and OCRB MEI. Okay, and also, yeah, bits of it may be appropriate for GCSE further maths and also the GCSE example as well. Okay, but I'll point it out as we go through. Okay, question number 1. Okay, is looking at week 1. Find the value of P for which the equation P minus 3 lots of x squared plus px plus 3 equals 0 has a repeated root. So this is all to do with when the discriminant, i.e. b squared minus 4ac, when that's equal to 0. This is the bit inside the square root. If it's equal to 0, then it has what we call, a repeated root. Okay, so a is equal to p minus 3. Okay, remember a is the coefficient of x squared. B is the coefficient of x, so the number in front of the x or term in front of the x. Okay, in this case here, it's just going to be p. Remember, p is just a constant, and c is the constant, coefficient at the end, or the constant number at the end. Okay, the number at the end is just 3. So I'm now going to sub this into my equation. I'm going to have p squared, okay, subtract 4 lots of all this. So 4 times 3 is 12, times it by this. I'm going to have minus 12p plus 36k. So it's 4 lots of p minus 3 times 3. If you're not sure, I'll do it here. So you got minus 4 lots of p minus 3, and then times that also by 3. Okay, when you times all this out, it gives you minus 4p plus 12. Okay, so minus 4p plus 12. Okay, times that by 3, and you get minus 12p plus 36. Okay, I hope that makes sense. Okay, because minus 4 times 3 is minus 12, so you have minus 12 lots of all this. So minus 12p plus 36. Okay, so that's going to be equal to 0. I've now got a quadratic here that I can factorize. Okay, so two numbers that add to make minus 12 and times to make 36 will actually be 6 and 6. So we're going to have p minus 6 times p minus 6. And hopefully you can see here that I'm going to have p is equal to 6 twice. Okay, repeated root. Okay, so the value of p here will be equal to 6. Okay, so 6 is repeated twice. Okay, so you have p equals 6 there. Okay, I'm going to put here obviously brackets twice. Okay, and this is what I mean by a repeated root. Okay, because you have p minus 6 here, which is equal to 0, and also p minus 6 is equal to 0. If you solve both equations, you will get 6 twice. Hence why I write p equals 6 brackets twice there, repeated root. Okay, that just means that the quadratic touches, the x-axis at 6. Okay, so when p is 6, okay, the quadratic, okay, touches the x-axis at one particular point. Okay, and again, I'll cover that more in the future. Okay, but the key to remember is that when it's a repeated root, it means that the discriminant is equal to 0. So the bit underneath or inside the square root as part of the quadratic formula, okay, b squared minus 4ac is equal to 0. Okay, what about this next one? Okay, week 2. Okay, question 2. Find the values, okay, so values, so plural, of p, which the equation px squared plus 2px plus 3 equals 0 has no real solution here, or no real roots. Again, that's when the discriminant is strictly less than 0. So we have b squared minus 4ac is less than 0. Okay, so we are going to end up forming and solving, I think, a linear or a quadratic inequality. So a equals p, b equals 2p, and then c equals plus 3. I'm not going to sub all this here into my inequality here. Okay, obviously being careful here. So we're going to have 2p all squared. So that's going to be 4p squared. Okay, subtract 4 times p times 3. Or 4 times p is 4p times by 3. So that'll be minus 12p. Okay, that's going to be less than 0, guys. Again, sorry about lack of spacing. Okay, I'm not going to factorize this quadratic. So I'm going to take out 4p as a factor. Okay, or even p as a factor. Okay, either way is going to be fun actually. Yeah. Okay, but I'm just going to fully actually factorize here for the purpose of this video. Okay, but yeah, so 4p times what makes 4p squared? Well, that'd be p. Okay, 4p times what makes minus 12p? That'd be minus 3 or negative 3. Okay, that's going to be strictly less than 0. So when is this quadratic? Obviously below the x-axis. So the roots would be at 0 and 3. Okay, essentially. So when is this? When is the curve below the x-axis? Well, it's below it between 0 and 3. So the values of p will be when p is greater than 0, but also less than 3. Okay, yeah, like simultaneously. Okay, yeah. So when 0 is less than p, which is less than 3. Okay, so that is the values of p for which the quadratic equation has no real roots. Okay, so when b squared minus 4ac is strictly less than 0. Okay, when it's less than 0. Okay, when it's a repeated root, it's equal to this 0. When it's two distinct real roots, that's when the inequality b squared minus 4ac is greater than 0. Okay, so remember that for AS pure maths. Okay, question 3. Find the equation of the line parallel to the line 2y plus 4x equals 7, passing through the point 1,5. So parallel means it has the same gradient. So I'm going to rearrange it in the form y equals mx plus c. So I'm going to subtract 4x and then divide by 2. So when I do that, I get y is equal to minus 2x plus 7 halves, or plus 3.5. Okay, either way is fine. Okay, so this equation has a gradient of minus 2. Okay, so my new equation will be in the form y equals minus 2x plus c. I can now substitute the coordinates, okay, 1, 5 in this form. So we're going to have 5 is equal to minus 2 times 1, which is minus 2, plus c. So rearrange here to make obviously c here the subject. So add 2 to both sides here. So we're going to have 7 equals c. So c is equal to 7. So far, my answer is y is equal to minus 2x plus 7, but we want it in the form ax plus by is equal to c. Okay, so I'm going to add 2x to both sides. Okay, when I do that, okay, we're going to have y plus 2x equals 7, or I can rewrite it as 2x plus y equals 7. Okay, where a is equal to 2, b is equal to 1, and c is equal to 7. Okay, so remember, parallel lines from GCSE maths means, they have the same gradient, so the same coefficient of x in the form y equals mx plus c, so the same value of m, for the gradient, okay? So I minus 4x and then divided by 2, okay? So I had 2y equals minus 4x plus 7, and then I divided it by 2, okay? So I've got y equals minus 4x plus 7 all over 2, okay, or minus 4x over 2, which is minus 2, plus 7 over 2, or 7 halves, or 3.5, 3.5. I then deduced that my gradient here was equal to minus 2. So my equation here of the new line, okay, was y equals minus 2x plus c. I then substitute here the coordinates 1, 5, okay, so x is 1, y is 5, into there to work out the value for c. And then once I worked out what c is, I rearranged the equation to make it in the form ax plus by plus c. Okay, but of course, if you're a GCSE student, then obviously, leave it in the formula y plus mx plus c. But again, obviously A-level maths, get in the habit of like rearranging your equations so it's in the formula that they wanted, okay, especially for OCR A and OCR MEIB or OCR B MEI. Okay, question number 4. So use the bottom expansion here to write down the first 4 terms of the expansion 1 plus 2x all to the power of 7. Okay, so this is quite an important topic. Okay, so we're going to use here what we call Pascal's triangle. So we start with 1, then we have 1, 1, then we have 1, 2, 1. Okay, we have 1, 3, 3, 1. Then we have 1, 4, 6, 4, 1. Okay, might be going to be a bit off screen here. 1, 5, 10, 10, 5, and 1. And we have 1, 2, 3, 4, 5, 6. Yep, this one's 7. 1, 6, 15, 20, 15. Okay, 6 and 1. And again, don't panic too much here. But essentially, what I'm doing is, so to work out the middle term here, you add the 2 like terms above it to work out the middle term. And then so essentially it's like it's what I call like a Pascal's triangle, and it follows this pattern there. Okay, but don't worry at this stage here. Obviously, I'll do a video here that will actually cover this into like more actually details here. But for now, just obviously try and remember here. So start off with 1, then you have 1, 1, then you have 1, 2, 1, then you have 1, 3, 3, 1. Okay, it's always ones here at the edges, and then the next term is worked out by adding the 2 terms that are directly obviously above it. Okay, okay. So we want this 7th line here. Okay, so we're gonna have it in the form. Okay, so we're gonna have 1 to the power of 7. Okay, obviously so we've got obviously 1 there times by 1 to the power of 7 times by 2x to the power of 0, okay? So the way this works is that your powers, okay, when you multiply, like these numbers separately, must add to equal this n power, okay? 7 plus 0 makes 7. Okay, so that is, my first term. When I work this out, I'm going to get 1. Okay, so that's my first term. Okay, next one. Well, I'm going to obviously, increase the power of this by 1, and then knock 1 of this power, okay? But obviously, the next one here is going to be 6. So I'm going to have 6 lots of, I'm going to have 6 lots of 1 to the 6 now, and then 2x to the power of 1. So 1 to the 6 is equal to 1 times by 6 here makes 6 times by 2x. So I'm going to have plus 12x, okay? That's now my second term. And then my third term now is going to be the third number here, which is going to be 15. Okay, so looking at this row here, guys, to obviously make it obviously quite clear. So looking at this row here, okay, we're going to have 15 times 1 to the power of 5, okay, times 2x all squared. Okay, remember the powers have to always add to make 7 in this case, okay? So let's work it out. 2x all squared, that'll be 4x squared, okay? Because remember, it's 2 times 2, which is 4x times x makes x squared. Okay, times it by 1 times it by 15 here. So that'll be plus 60x squared. Oops, sorry, I've got that on there. Sorry, So plus 60x squared. And then my fourth and final term is fourth and final term. Okay, there's 4. Okay, we're gonna have 20 times by, now I forgot what I've done actually. So 1 to the 7, 1 to the 6, So it'll be 1 to the 4. And then times by 2x all cubed. Okay, remember, the powers have to add, in this case here, to make 7. So 4 plus 3 makes 7, okay? And then this is my constant, NCR number, okay? For the fourth term. So that'll be 8x cubed times it by 20. So that'll be 160x cubed. Okay. I'm gonna just put plus obviously dot here, so plus dot. Okay. And that, guys, is my first 4 terms, of the expansion 1 plus 2x power of 7. Okay. Now, if it's new to you, don't actually panic. Okay. I mean, you could have technically expanded like the first 3 brackets. Okay. Because you've got the first 2 would have given like the first 3 terms. Okay. Yeah. And then that would have also given you like the same answer. But again, don't actually panic here too much. You'll obviously learn that in more detail. In your A-level classes. Okay, but this topic here is called like binomial, like expansion, like Pascal's triangle. Looking at like NCR, like factorials. Okay, but again, obviously I'll cover that more. Okay, but the key is to try and like learn, and like memorize like Pascal's triangle. Okay, because it'll tell you, like the coefficients, of like where like the terms go, if that makes sense. Okay. Okay, week 5, week 5, or question 5. So find the gradient of the tangent to the curve y equals x cubed minus 2x squared plus 2x minus 1 at the point minus 1 minus 6. So step 1, we're obviously going to differentiate. So find dy by dx. So find the first derivative. Okay, f dash of x or f prime of x, or the first derivative. Okay, so the power comes down here as a multiplier, and the power, reduces by 1. So that's going to be 3x squared minus 2x squared, differentiates to minus 4x. And then 2x obviously goes to just 2. And then the minus 1, remember if it's a constant, obviously goes to 0. So that obviously goes to 0. I'm not going to sub in minus 1 into here to work out my gradient at that point. I'm going to have 3 lots of minus 1 squared. So that'll be 3 minus 4 times minus 1. That'll be plus 4. And then subtract 2 it. Plus 2. Plus 2 at the end. Should be a plus 2 there. Sorry about that, guys. Okay, it's my fault. Okay, so 2x differentiates here to just 2. Okay, and then the minus 1 over here goes to 0. Okay, if you differentiate constant, always goes to 0. 3 plus 4 is 7, plus 2 is going to be 9. Okay, I'm not going to use the formula y minus y1 equals m brackets x minus x1. So I'm going to have y plus 6. Okay, so remember that's y1. Okay, so y minus 6 becomes y plus 6 is equal to m brackets x minus x1. So m is going to be equal to 9 brackets x minus 1 becomes x plus 1. Okay, expand this bracket out, subtract 6 on both sides. What we're going to get, guys? Well, we're going to get y is equal to 9x plus 9 minus 6. So we're going to get y. Sorry, I'll do it out in full here. Sorry, I'll do it actually in full here, just so you can see. So y plus 6 is equal to 9x plus 9. Subtract 6 on both sides. Okay. We have y is equal to 9x plus 3. Oh, sorry, he's asking for Greenwich. Sorry, Greenwich. Sorry, not the Queen's tangent. Sorry, I apologize. That's my fault. Okay, sorry. Okay, sorry. I've done like a little actually bonus marks here. So that is my tangent. Sorry, tangent equation. Okay, but the actual gradient. Sorry, actually, okay, sorry, actual gradient is equal to 9. Okay, equal to plus 9. So m is equal to positive 9. Okay, or just 9. Okay, sorry about that. It's my fault for actually reading it carefully. Okay, but the gradient, at the point minus 1 minus 6 is equal to positive 9 or just 9. Okay, so we found the first derivative by differentiating it. Okay, remember the power comes down as a multiplier and the power goes down by 1. So the power reduces by 1 and the power comes down here as a multiplier, and then we knock 1 off the power. And lastly, if you differentiate a constant, it always goes to 0. Okay, but again, you'll obviously cover that, hopefully after the October half term, or just before the October actually half term. But that, guys, is like the first few topics here that I've covered obviously in one go. Okay, for the AS Pure Maths. So it will be useful for your upcoming end of term mocks, or anyone that is resitting AS Pure Maths, or even the full A-level maths. Okay, thanks for watching. Like, subscribe, share for more content like this. Okay, bye for now. Okay, happy Friday. Okay, enjoy your weekend. Okay, bye for now. Okay, is end of September. Okay, bye for now.